Now we're going to simplify complex fractions. A complex fraction is a fraction within a fraction. Let's look at an example. Alright, so this is our first example. To get rid of the fraction in the numerator, x over 4, we have to think of what number can we multiply this whole fraction, meaning the numerator of this fraction line and the denominator of this fraction line. What can we multiply it by so that our numerator, this turns into or gets rid of that fraction. So that number, we're actually going to multiply this one by 4 over 4, because look what happens when you distribute the 4 to the numerator. Alright, so then what it equals is 4x over 4 minus 12. And then you have on the bottom 4x plus 8. So then when you simplify it, you get x minus 12 over 4x plus 8, but what we can really do is leave it in factored form, because if you remember in class the other day, factored form helps us identify the restriction that we have to put on the denominator. So that our answer is not complete yet, and we have to add x cannot equal -2. So this is the simplified version of our problem. Alright, so this is our next example. Now this one's a little bit more complex because instead of just having a constant on the denominator, we have a polynomial. Not only do we have one polynomial, but we have two, right here and right here. So just like the first problem when we had to choose 4 to multiply it by because it got rid of the denominator, we're going to have to multiply this whole fraction in this parenthesis by x plus 5 to get rid of this fraction, and then also x plus 1 because we have two complex fractions. Alright, so let's see what that looks like. Go ahead and try and see, and then pause this video, and then see if you get the same thing I do in a second. So this is what our fraction would now look like after distributing the x plus 5 and x plus 1 on the numerator and the denominator of the fraction this whole fraction, the fraction that's represented by this fraction bar. Okay, so now what we can do is we can start to cancel things out. So x plus 5 cancels out in the first fraction, and then in this part x plus 1 cancels out, which is ultimately what we wanted to happen. So now our problem will look like this. So this is now what our fraction looks like, which is what we needed because it's no longer a complex fraction. So the next step that we will have to take is to distribute these two binomials and then also this x, be careful of this minus sign, to see how we can simplify this whole fraction now. Alright, so we're going to get x squared plus 5x plus 4 minus x squared minus 5x because I distributed all in the same step. Alright, so this is just a numerator. I'm not going to write it over the denominator again because I'm going to keep simplifying this, and then at the very end I'll put it over the denominator. So now we have our x squareds actually cancel out. We have x and then negative x squared, and the same thing happens with our 5x's. So now we actually simplify all the way down to 4 over, now I'm going to bring in our denominator, 4x plus 5 times x plus 1. And here we go. We can simplify one more time, and these 4's now can cancel out. And our final answer is 1 over x plus 5, x plus 1, and don't forget that last part, x cannot equal -5 or -1. Alright, so this is our third and our last example for complex fractions, and we'll do a lot more practice in class on Tuesday. The first thing that I'm going to do is, since I look at this right here and this is one complex fraction, I need to know what I'm going to multiply by so that this cancels out. So the first thing I'm going to do is rewrite this, And I'm actually going to factor that really quickly. So it's going to be x minus 1, and then here we go, minus 3 over 1 minus 1 over x plus 1. Oh, I'm sorry, I'm going to fix this. I didn't mean, this wasn't supposed to be plus 1. Your first, here we go. This problem was supposed to be x minus 1 because I needed those two to be the same. All right, so now that I did make the complex fractions in the numerator and now we have one in the denominator, since I made them both x minus 1, it's going to make this one just a little bit simpler. We won't have to multiply by so many things. So luckily, like I just said, we are going to multiply this whole thing by x minus 1 because it's going to help get rid of this denominator in our whole problem, our whole fractions numerator. So we're going to also multiply that on the bottom because, you know, you always multiply by the same thing, and it will also help to get rid of that as well. So let's take a look and see what that looks like after we distribute those. All right, so this is after we distribute the x and x minus 1 on the numerator and the denominator of our big fraction, this whole fraction, not the little fractions inside, this is what it turns out to look like. And I know this looks really crazy, but this is what we wanted because if you can tell, our x's cancel out here and here, which gets rid of that fraction. And then our x minus 1's cancel on the denominator, which in the end gets rid of the fact that we have a complex fraction. So if you didn't see how I distributed that, take a second and pause the video and look at it to see if you can see why or how I got this far in this problem. All right, so let's move on to the next page and take a look at what this looks like without, you know, my big lines and it all simplified. All right, so now we got rid of our complex fraction, which was our goal. We're going to distribute up top in the numerator so that we can simplify. And now we're also going to do the same thing in the denominator. All right, and just like we did before, we can now just factor out that bottom to see if anything can cancel. Our numerator won't factor, so that's going to stay the same. And then factoring the denominator is just going to help us see our restriction. All right, so our final answer is this fraction, but x cannot equal 0 or positive 2. So this is our final answer. All right, so these are the 3 examples that I just was going to show you guys in class, but now that you're doing it at home, if you have any questions, star it on your paper so that you know when you ask me or come see me Monday morning. And we're going to do a whole bunch more practice in class. This is a concept that is probably one of the toughest parts of this unit, so make sure that you get all your questions answered. We're going to do a lot of practice in class and just keep asking questions. And honestly, the best way to study for this stuff is just to keep doing practice problems. All right, see you guys on Tuesday.